Hello, warriors. This is Mrs. Kuklo, and today we're going to be talking about another part of data analysis. We're going to be learning about mean absolute deviation. Mean absolute deviation, the definition is when you find the mean absolute deviation of a data set, so that'd be like a list of numbers, it's the average distance between each data value and the mean. Mean absolute deviation is a way to describe variation in a data set. Variation is how consistent data is. So if there's a lot of variation, that means it's really spread out. If there's a little bit of variation, that means the numbers are closer together, so they're more consistent. So mean absolute deviation's purpose is to help us see how spread out our values are. So we can see if they're consistent. If there is a small mean absolute deviation, that means the numbers are pretty close together. They're very consistent. If there's a large mean absolute deviation, that means that they're really spread out. So they're not as consistent. So our first question says, what is the mean absolute deviation of this data set? Notice it is a dot plot. If you forgot how to read a dot plot, each of these dots represents a number. So this is 0, 0, 2, 4, 5, 5, 7, 8, 9, and 10. To find the mean absolute deviation, the first thing that you have to do is find the mean. And as we learned earlier this week, mean is the same thing as the average. So you would first add all those numbers together. 0 plus 0 plus 2 plus 4 plus 5 plus 5, because there's two dots there, so there's two 5s, plus 7 plus 8 plus 9 plus 10. And you are allowed to use a calculator for that part. So when I added them all together, I got that the sum was 50. And then we divide by how many numbers there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. So there are 10 numbers in our data set. So our mean is 5, which you can see they already showed us that the mean was right there with that triangle. So the first step in finding the mean absolute deviation is to find what the mean is, because now we want to see how far apart are all of these numbers from the mean. And that is the second step. Remember, this is a Kami, so you can zoom way in if you need to. I'm sorry, I didn't give a lot of space to write here, so you are going to need to zoom in. So the easiest way to do this is to make a second dot plot. And I have been teaching mean absolute deviation for years, and I found this method on a video on YouTube, and I thought, oh my gosh, this makes it so easy to understand. So we had 2 zeros. And I need to know how far away is 0 from 5. We don't care about positives and negatives. That's what the absolute part means, like absolute value. We just care how far away it is. We don't care which direction it is in. So in math, to figure out how far away something is, we subtract it. So we can subtract each number from the mean. So 5 is the mean, minus 0, that would be 5 away. So we have two numbers that are 5 away. We had 2 zeros, so we put 2 5s on this plot. This is just a way to help us organize our numbers. And then I have a 2. So once again, you can subtract, or you could just count 1, 2, 3 away. So 5 minus 2 is 3 away. So I put a 3 right there to show that that 2 is 3 away from the mean. And then 4 is 1 away. You could do 5 minus 4 if you need to, but I think we know that's one step. Then we have 2 numbers that are right on the mean. That means they're nowhere away from it because they are the same as the mean. So we had a 0 and a 0 because they're 0 away from the mean. And then I'm going to continue to subtract. You probably could figure out that that's 2 away, but I want to keep reminding people that to find how far away each number is from the mean, we would subtract it. So 7 is 2 away from the mean. And then 8 is 3 away from the mean. So I put a 3 right there. And then 9 minus the mean is 4. So 9 is 4 away from the mean. And then 10 is 5 away from the mean, because I could do 10 minus 5 to get 5 away. So step 1, we found the mean of the data. Step 2, we made another plot to organize our numbers, because our next step is to find the mean, find the average of all of those numbers, find the average of how far away each number is from the mean. So we're finding the average of those numbers we put on our second dot plot. So I'll add 5 plus 5 plus 3 plus 1. See, I'm just getting the numbers from the dot plot. 5 plus 5 plus 3 plus 1 plus 0 plus 0, because we had 2 dots there, so we had 2 zeros, plus 2 plus 3 plus 4 plus 5. And I always go back and double check to make sure that I have not missed a number. 5, 5, 3, 1, 0, 0, 2, 3, 4, 5. So I did not miss any numbers. When you find the average, you add them all up. When I add them, I get 28. And there are still 10 numbers because we were figuring out how far each of our numbers was away from 5. So there's still 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we still divide by 10 to get that the mean absolute deviation is 2.8. What that means is that each of our numbers is an average of 2.8 away from the mean. Just like with all averages, some of them will be a little bit higher because 5 is a little bit further away than 2.8. And some of them will be closer, like the zeros are exactly on the mean. But the average number, the average distance away from our mean is 2.8 for this problem.